This is a lesson for 3-4 direct variation. What you're doing today is basically making a graph of a word problem and then answering some questions about the problem situation as well. So this is called direct variation. Indirect variation, what direct variation is a constant rate of change. So you're multiplying something by the same number each time. So you're going to get equations today that look like y equals 2x or y equals 7.75x or y equals 10x. Your slope, which we learned in the previous section, is the number that's in front of the x. That's also your rate or rate of change. That 2, that 7.5 and 7.75 and that 10 that's in front of the x. Your slope or your rate always goes in front of the x. In today's particular questions, you're not going to have a plus or minus after the x. We're just going to put our rate in front of the x because we're always going to be starting at 0. So let's take a look at this first one. Julie made $48 for 6 hours of work. Find her hourly rate and graph her total earnings per hour for the 6 hours. Now, when you go to start this one, all right, first of all, we always need a title for our graph. So let's say that this is Julie's earnings. Always make sure that your graph has a title. Now, when you go to label your axes, all right, we always want units of time at the bottom. So our unit of time, she made $48 for 6 hours of work. We're going to put time along the bottom of our graph. And because it says 6 hours, we don't need to figure out what 7 or 8 or 9 hours are, but we're always going to start at 0 at the big, thick black line. And then we're going to count by ones here. So 0, 1, 2, 3, 4, 5, and 6. We don't need to go any farther because the word problem says 6 hours. If it said 10 hours, then we keep on going to 10. So now we need to find her hourly rate, all right? The amount of money she makes, that's going to be our label for the y-axis here going up. When we go to find her hourly rate, you always find the hourly rate by dividing, all right? You're always going to divide to find the hourly rate. So she made $48 for 6 hours. So when we go to find her hourly rate, 48 divided by 6. 48 divided by 6, she is making $8 per hour. When you go to write your equation, your rate always goes in front of your x. So you're always going to have a y equals, you're always going to have an x. Whatever your rate is goes in front of the x. So we're going to put that right here. This is your equation, y equals 8x. So how much would she earn after $40? Well, you could do this question at any point in time. If we wanted to figure out how much she made for 1 hour, we would sub in a 1 there. 8 times 1 is 1. If we want to figure out how much she made after 2 hours, 8 times 2 is 2. We want to know how much she makes after 40 hours. So what we're going to do is we're going to take that 40 and we're going to sub it in for X. She's making $8 an hour. She's working for 40 hours. So we're going to multiply those two things together. 8 times 40. After 40 hours, she's going to make $320. Well, now what we want to do is we want to graph this, all right? We want to graph y equals 8x. Just like we did in the previous sections, it's sort of like graphing using the chart method that we did in 3-1. I'm going to make a little chart for myself. So our equation is 8x, all right? So we're going to put 8x there. We need to figure out how much she earns after 0, 1, 2, 3, 4, 5, and 6 hours. So I'm going to put that in as my x values. And now we just have to sub them in, just like we did in 3-1. Instead of 8 times x, I have 8 times 0. 8 times 0 is 0. You work 0 hours, you earn $0. Work 1 hour. 8 times 1 is 8. Work 2 hours. 8 times 2 is 16. Work 3 hours. 8 times 3 is 24. Work 4 hours. 8 times 4 is 32. Work 5 hours. 8 times 5 is 40. Work 6 hours. 8 times 6 is 48. So now that we have our chart filled out, now we want to graph it. When we go to graph it, this is your number of hours. All right, this is along our x-axis. So this is how many we're going over. And then this is our y-axis. Our y-axis is really our amount of money that she's earning. That's how many, when we go to graph it, that's how many we're going up. So their first point is 0, 0. So we're going to put a dot right here. Now you need to figure out what we want to count by going up along the side. You can technically count by whatever you want to. If you wanted to count by 5s, fine. If you want to count by 10s, fine. It just has to fit on the graph that you have, all right? So our highest number is 48. If we counted by 10s, it would be perfectly fine because it would fit, because we'd have 10, 20, 30, 40, 50. It'd have plenty of room. But I'm going to teach you a little trick that will make your life easier. Whatever your rate is, you should count by going up along the side. That's going to make things super, super easy to graph. So we're going to start off at 0, but then our rate, remember, is an 8. All right, this is our rate. So we want to count by 8s going up along the side. It's just going to make life easier to graph. Now, could you count by 10s? Sure. Might they on the state test give you an axis that counts by 10s already? Yeah, but you're going to have to make them yourself too. So I'm going to count by 8s going up along the side. 8, 16, 16 plus 8 is 24, 24 plus 8 is 32, 32 plus 8 is 40, 48. I could stop right there because I see that that is my biggest number. If you wanted to continue and do 56 and 64, that's fine, but you don't have to. So our first point is 0, 0. We already graphed that. 1, 8, over to 1, up to 8. 2, 16, over to 2, up to 16. 3, 24, over to 3, up to 24. 4, 32, over to 4, up to 32. 5 and 40, and then 6 and 48. We need to connect the dots, all right? We're going to connect the dots. They should always form a straight line. If they don't, you did something wrong. And then we always need an arrow on the end. Now, we don't put an arrow down at 0, 0 because an arrow signifies that it keeps on going. For example, if she works $7, it's going to keep, or 7 hours, it would keep on going over to the right. But we can't go to the left because number one, it's impossible to work negative hours. And number two, it's impossible to earn negative dollars. So this is one complete question. You have your title, your 2 labels of dollars and hours. We graphed our line, we put an arrow on the end, and we answered our 3 questions down here. Let's take a look at the next one. Yankee Stadium sold 5,000 sodas in 4 hours. All right. So calculate how many sodas per hour they sold and graph their sales for 4 hours. So I'm going to title my graph right away. This is soda sales. Your elements of time always go at the bottom. So we have hours again. You might have days, you might have years, you might have seconds. And then this is the number of sodas going up along the side. So it says for 4 hours, always 0 goes at the big black line. Then we have 0, 1, 2, 3, and 4. We don't need to figure out 5 and 6 in this one. Sodas sold per hour. This is your rate. So we always divide to find the rate. All right, always divide to find the rate. So we're going to do 5,000 sodas in 4 hours. So 5,000 divided by 4, that gives you 1,250. That is how many sodas sold per hour. When you go to write your equation, you always have a y equals and you always have an x. Whatever your rate is goes in front of your x. So this is y equals 1,250x. How many sodas would they sell after 6 hours? You would have to take this 6 and sub it in for x. So 1,250 times 6 gives you 7,500 sodas in 6 hours. Now we need to graph. So I'm going to make my table for my graph. I have my X column, I have my 1,250x, which was from my equation of my graph, and then I have my y column. So we need to figure out 0, 1, 2, 3, and 4. A little bit less work this time. So subbing in a 0 for the x, 1,250 times 0 is 0. 1,250 times 1 is 1,250. 1,250 times 2 is 2,500. 1,250 times 3 is 3,750. And 1,250 times 4 is 5,000. So now I have my points. Now remember, when you go to graph your points, your x value is how many we go over. Your y value is how many we're going to go up. So what do I want to count by going up along the side? Could I count by 1,000s? Sure. I can go 0, 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, and then graph it from there if I wanted to. However, make your life easy. Count by whatever your rate is. So if we go to count by the rate, I would have 0, 1,250, 2,500, 3,750, and 5,000. That's a little trick that just makes your life a lot easier if you count by the rate going up along the side. So now I'm ready to graph 0, 0. In 0 hours, they sell 0 sodas. In 1 hour, they're selling 1,250 sodas. 2 hours, 2,500 sodas. 3 hours, 3,750 sodas. 4 hours, 5,000 sodas. Remember that we have to connect the dots and put an arrow on the end. We don't put an arrow over to the left where 0, 0 is because they can't have negative hours. You can't sell negative sodas. So again, we have our title, we have our labels, we answered our 3 questions, we did our graph and put an arrow on the end. Now, the last type of question that we're going to have looks a little bit different. This time they're giving you the table, all right? In the previous question, we had to calculate, all right? We had to calculate the numbers. This time they're giving you specific numbers. You only have to graph these, all right? These are the ones that you have to graph. So it says the following table represents the number of days a restaurant was open and the total number of customers. So you have days and you have customers. When we go to do our graph, remember time always goes at the bottom. This time we're talking about days. The total customers goes up along the side. And we need a title for our graph. Let's call it restaurant customers. So graph the number of total customers per day, calculate the number of customers per day. This is your rate. We always divide to find our rate. Now, the nice thing with the table is we could choose any of the numbers and divide. I'm going to do the easiest one, which would be the smallest numbers. So 130 customers in 2 days. 130 divided by 2 gives you 65. I could have chosen any of those and divided. I could have done 195 divided by 3. That's 65. I could have done 325 divided by 5. That's 65. 390 divided by 6. That's 65. 455 divided by 7. That's 65. When you go to write your equation, we always have a y equals, we always have an x. Whatever your rate is goes in front of your x. So for our equation, we're just going to have y equals 65x. When you go to find your answer to your question here, how many total customers would there be after 12 days? Take this 12 and sub it in for x. So 65 times 12. 65 times 12 is 780. So now let's do our graph. Our biggest number is 7 days. Now, be very careful when you number the bottom down here. Yes, they skipped day 0, day 1, and day 4. You can't just write 2, 3, 5, 6, 7 across the bottom. We have to, when you do a graph, it has to be equally spaced along the bottom. Always put 0 at the thick, dark line. Then we're counting by ones. Yes, our data table does not have the 0, the 1, and the 4, but you need to include them down here. You can't just skip over numbers. Going up along the side, again, our biggest number that we're going to graph is 455. Could I count by 50s? Sure. Could I count by 100s? Sure. But make your life easy. Count by whatever the rate is. So if you just take your calculator starting at 0, keep on adding by our rate, which is 65. So 0, 65, 65 plus 65 is 130. 130 plus 130 is 195. And then 195 plus 65 is 260. Plus 65 is 325. Plus 65 is 390. Plus 65 is 455. So now we're ready to graph our points. We don't have 0, we don't have 1, all right, but we do have 2 and 130. Over to 2, up to 130, 3 and 195, 5 and 325, 6 and 390, 7 and 455. Now you should see that those dots do form a straight line. You're always going to start at 0, 0. All right, you're always going to start at 0, 0 because in 0 days they would have 0 customers. So we just need to eyeball it and connect the dots to form a straight line. Always make sure that you do put your arrow on the end. So that's what you're doing today. Make sure that you don't forget to title your graph. Make sure that you don't forget your labels, and make sure you don't forget the arrow on the end.